Hello guys, welcome back to the next session of Data Science with Python Programming. How are you guys? I hope everyone is fine and everyone is learning Python programming concept. Yeah, I hope you learn all the concept of Python programming and I hope you learn all the concept of data visualization. Yeah, so in this course till now we have seen introduction to data science part. After that we started with the Python programming concept. Yeah, and then we have seen introduction to data science libraries. Yeah, so under the data science libraries we have studied numpy, pandas, matplotlib, yeah, and seaborn also. So matplotlib and seaborn we have studied data visualization with matplotlib, data visualization with seaborn. Even we have studied three-dimensional plotting with the help of matplotlib. Okay, now it's time for us to proceed with the next point that is also very important for data science, that is introduction to statistical analysis. Okay, so now let me show you what you are going to learn in this session. So see, first of all you will learn what is statistical analysis. Okay, after that introduction to maths and statistics for data science. Okay, so it's important for you. Yeah, what knowledge of statistics you required for your data science. So we will see the introduction to the mathematics and statistics for data science. Okay, after that you will learn terminologies in statistics, statistics for data science. Okay, after that we will see categories in statistics, and then we will learn what is the correlation, and then mean, median, and mode, and finally quartile. Okay, now previously you heard about the mean, median, mode, quartile. Yeah, if you remember, the box plot shows the first quartile, second quartile, third quartile. Yeah, the middle line in the box plot shows the median. Okay, so you might think, what is this median? What is this mode? What is this quartile? So don't worry, in this session you will learn how to calculate the mean, median, mode, quartile. Okay, and even how can you write a program to find the mean, median, mode, and as well as quartile? How can you calculate it with the help of Python programs? Okay, so let's start with the first thing. What is statistical analysis? Yeah, do you know what is this? Tell me. Let me show you what is statistical analysis. So see, statistical analysis is the process of generating statistics from stored data and analyzing the result to reduce or infer meaning about the underlying data set or the reality that it attempts to describe. Are you getting the point? Statistical analysis is the process of generating statistics from stored data and analyzing the result to deduce and infer meaning about the underlying data set or the reality that it attempts to describe. It's the science of collecting, exploring, and presenting large amount of data to discover underlying patterns and trends. Okay? Statistics are applied every day in research, industries, and government to become more scientific about the decision that need to be made. Are you getting the point? Yeah. Statistics are applied every day, okay, in research field, in industries, and in government to become more scientific about the decision that need to be made. Okay. And statistical analysis, it is the science of collecting, exploring, and presenting the large amount of data to discover underlying patterns and trends. Okay. For example, as we are saying that statistics are applied every day in research, industry, and government to become more scientific about the decision that need to be made. So let me show you the example where it is used. So see, for example, manufacturers use statistics to view quality into beautiful fabrics, to bring lift to the airline industry, and to help guitarists make beautiful music. Yeah, and to help guitarists make beautiful music. Researchers keep children healthy by using the statistics to analyze data from the production of viral vaccine, which ensure consistency and safety. So it's also very important. Yeah, researchers are using statistics. Okay, researchers keep children health by using statistics to analyze the data from the production of viral vaccine, which ensure consistency and safety. Okay, communication companies use statistics to optimize network resources, improve service, and reduce customer churn by gaining greater insight into the subscriber requirement. Government agencies around the world rely on the statistics for a clear understanding of their countries, their business, and their people. So you might think, what is the importance of statistics? Yeah, okay. So what is statistical analysis? Statistical analysis is a process of generating the statistics from the stored data and analyzing the result to reduce or infer meaning about the underlying data set or the reality that it attempts to describe. It is the science of collecting, exploring, and presenting the large amount of data to discover underlying patterns and trends. The statistics are applied every day in research, industry, and government to become more scientific about the decision that need to be made. So you can see the example where the statistics are applied, where the statistics is useful. So the first example, manufacturers. Yeah. So manufacturers uses the statistics to view quality into the beautiful fabrics, to bring lift to the airline industries, and to help guitarists make beautiful music. Researchers keep children healthy by using the statistic to analyze the data from the production of viral vaccine, which ensure consistency and safety. Communication companies use statistics to optimize the network resources, improve services, and reduce the customer churn by gaining the greater insight into the subscriber requirement. And finally, the government agencies around the world rely on the statistics for a clear understanding of their countries, of their business, and their people. Are you getting the point? Yeah. Now let's proceed to the next point. Introduction to maths and statistics for data science. Yeah. So see, a Josh Wills once said, data scientist is a person who is better at statistics than any programmer and better at programming than any statistician. Are you getting the point? Yeah. Josh Wills once said, yeah, a data scientist is a person who is better at statistics than any programmer and better at programming than any statistician. Yeah, math and statistics for data science are essential because these disciplines form the basic foundation of all the machine learning algorithms. Okay, now you might think, what is machine learning algorithms? What are the types of machine learning? How to implement the algorithms under the machine learning? So don't worry, we will soon start learning the machine learning, the types of machine learning, what are the algorithms under the supervised machine learning, unsupervised machine learning. Okay, we will see all those things. Okay. In fact, mathematics is behind everything around us, from the shapes, patterns, and colors to the count of petals in a flower. Mathematics is embedded in each and every aspect of our lives. Okay? Yeah. So, as Josh Wills once said, data scientist is a person who is better at statistics than any programmer and better at programming than any statistician. Maths and statistics for data science are essential, very important, because these disciplines from the basic foundation of all the machine learning algorithms. Yeah, these disciplines form the basic foundation of all the machine learning algorithm. In fact, mathematics is behind everything around us, from shapes, patterns, and the colors to the count of petals in a flower. Mathematics is embedded in each and every aspect of our lives. Okay? Although having a good understanding of programming language, machine learning algorithm, and following a data-driven approach is necessary to become a data scientist. Okay? So see, although having a good understanding of programming language, so you're learning data scientist with the help of Python. So you already know all the concept of Python. Yeah, we have seen. And then the machine learning algorithms and following a data-driven approach is necessary to become a data scientist. So till now you have learned the concept of Python programming and you have also learned the data visualization. So very soon we will start learning the machine learning algorithms and we will start predicting the values. Yeah, how the machine learning algorithms help us, yeah, to predict the outcomes or to predict the values. Okay, we will see that. And what are the algorithms are there under the machine learning? Okay, under the supervised machine learning, under the unsupervised machine learning, how this machine learning algorithms is going to help us, yeah, to make a decision, yeah, or to find or to predict the values. We are going to see that. Okay, so I hope now you understand introduction to mathematics and statistics for data science. Yeah. So remember, statistics and mathematics are important for data science. Yeah. A good understanding of programming, machine learning, algorithm, and following a data-driven approach is necessary to become a data scientist. Okay. And by the way, mathematics and statistics for data science are essential because these disciplines form the basic foundation of the all the machine learning algorithms. And in fact, mathematics is behind everything around us, from the shapes, patterns, and colors to the count of petals in a flower. Mathematics is embedded in each and every aspect of our lives. Okay, now let's see the introduction to the statistics. Okay, so see, to become a successful data scientist, you must know your basics. Math and statistics are the building blocks of the machine learning algorithms. Got the point? So see, in order to become a successful data scientist, you need to have a good understanding of programming language, machine learning algorithms, and a data-driven approach. Yeah, having a good understanding of programming language, machine learning algorithms, and following a data-driven approach is necessary to become a data scientist. So see here, math and statistics are the building blocks of machine learning algorithms. So before going to start machine learning algorithms, so you should know some terminologies about the statistics. Okay, so mathematics and statistics are the building blocks of the machine learning algorithms. It is important to know the technique behind various machine learning algorithms in order to know how and when to use them. Now the question arises, what exactly is statistics? Yeah. So as we are saying that to become a successful data scientist, you must know your basics. So mathematics and statistics are the building blocks for the machine learning algorithms. And it is important to know the technique behind various machine learning algorithms in order to know how and when to use them. Now the question arises, what exactly is statistics? So see here, statistics is a mathematical science pertaining to the data collection, analysis, interpretation, and presentation. Statistics is used to process complex problems in the real world so that data scientists and analysts can look for a meaningful trends and changes in data. In simple words, statistics can be used to derive the meaningful insight from the data by performing the mathematical computation on it. Got the point? What is exactly statistics? Statistics is a mathematical science pertaining to the data collection, analysis, interpretation, and presentation. Statistics is used to process the complex problem in the real world so that the data scientist and analyst can look for the meaningful trends and changes in data. In simple words, statistics can be used to derive meaningful insight from the data by performing the mathematical computation on it. Got the point? Yeah. Now let's proceed to the next point. Terminologies in statistics. Yeah, that is statistics for data science. So see, one should be aware of a few key statistical terminologies while dealing with statistics for data science. Okay, you should be aware of a few key statistical terminologies while dealing with the statistics for data science. So see, first terminology come here, population. So see, population is a set of sources from which data has to be collected. Okay, so see, for the statistical analysis, obviously we need to perform the analysis on the data. So from which the data has to be collected, that is nothing but the population. So population is a set of sources. Population is a set of sources from which data has to be collected. So what are the set of sources from where we can collect the data? That is nothing but population. So this is one of the term. Okay. So population is a set of sources from which data has to be collected. Yeah. In simple term, what can you say about statistics? In simple word, statistics can be, yeah, in simple word, statistics can be used to derive the meaningful insight from the data by performing the mathematical computation on it. Okay. So obviously we need to perform the mathematical computation on the data. So from where we need to collect? So the population, this term is a set of sources from which data has to be collected. Okay. Now the next term is sample. So see, a sample is a subset of the population. Population is a set of sources from which data has to be collected. A sample is a subset of the population. Okay. After that, you can see a variable. A variable is any characteristics, numbers, or a quantity that can be measured or counted. A variable may also called a data item. Okay, a variable may also called a data item. So we are learning the terminologies related with the statistics, which is important for your data science. So you might think, what is a variable? So we have seen the variable in case of Python also. Yeah. But in case if you are thinking about the statistics, so a variable is any characteristics, number, or a quantity that can be measured or counted. A variable may also be called a data item. Okay, also known as a statistical model. A statistical parameter or a population parameter is a quantity that indexes a family of probability distribution. For example, the mean, median, etc. of a population. So what are the mean, what are the medians of the data? We will see that in this session also. Okay. So these are the some terminologies you should know. Okay. In data science. So these are the terminologies in statistics for your data science. So what is a population? Population is a sort of sources. It is a sort of sources from which data has to be collected. A sample is a subset of the population. A variable is any characteristics, number, or a quantity that can be measured or counted. A variable may also be called a data item. Also known as statistical model. A statistical parameter or a population parameter is a quantity that indexes a family of a probability distribution. For example, the mean, median, etc. of a population. We will see that how to calculate mean, median. Okay. So these are the terminologies in statistics for the data science. Okay. Now let's proceed to the next term. Next point. Categories in statistics. So see, there are two main categories in statistics, namely descriptive statistics, inferential statistics. Okay, these are the two main categories in statistics. So first one is descriptive statistics and the second one is inferential statistics. So let's understand descriptive statistics. So see here, descriptive statistics uses the data to provide description of the population either through the numerical calculation or graph or tables. Descriptive statistics uses the data to provide the description of the population, either through the numerical calculation or the graph or tables. Descriptive statistics helps organize data and focuses on the characteristics of the data providing parameters. Okay, so descriptive statistics uses the data to provide the description of the population, either through the numerical calculation or through the graph or through the tables. Descriptive statistics help organize the data and focuses on the characteristics of the data providing parameters. Okay. It deals with the quantitative description of the data through numerical representations or graph. Descriptive statistics deals with the quantitative description of the data through numerical representations or graphs. Suppose you want to study the average height of the student in a classroom. What do you want to study? Suppose you want to study the average height of the students in your classroom. In descriptive statistics, you would record the height of all the students in a class, and then you will find out the maximum height, the minimum height, and the average height of your class. Are you getting the point? Descriptive statistics deals with the quantitative description of the data through the numerical representation or through the graphs. Suppose that you want to study the average height of the students in the classroom. In descriptive statistics, you would record the height of all the students in the class, and then you would find out the maximum height, the minimum height, and the average height of the students in your class. Got the point? So what is the descriptive statistics? So descriptive statistics deal with the quantitative description of the data through the numerical representation or graph. Descriptive statistics uses the data to provide the description of the population either through the numerical calculation or the graph or the tables. Descriptive statistics help organize the data and focuses on the characteristics of the data providing parameters. Got the point? And it deals with the quantitative data description. Yeah, quantitative description of the data through the numerical representation of a graph. And then this is the example of it. Suppose that you want to find out the average height of the students in your class. Okay, so in descriptive statistics, you would record the height of all the students in the class, and then you would find out what is the maximum height of the student, what is the minimum height of the student, and what is the average height of all the students in your class. Got the point? Yeah. Now let's proceed to the next category of statistics, that is inferential statistics. So see here. Inferential statistics makes inferences and predictions about a population based on a sample of data taken from the population in question. Inferential statistics generalizes a large data set and applies the probability to arrive at a conclusion. It allows you to infer parameter of the population based on a sample statistics and build models on it. Okay. Inferential statistics makes inference and a prediction about a population based on a sample of the data taken from the population in a question. Inferential statistics generalizes a large data set and applies the probability to arrive at a conclusion. It allows you to infer parameters of the population based on the sample statistics and build models on it. So let's see the example so that you will understand inferential statistics. So see, a company is thinking about buying 50,000 electric batteries from a manufacturer. It will buy the batteries if no more than 1% of the batteries are defective. It is not possible to test each battery in the population of 50,000 batteries since it takes time and cost money. Instead, it will select few sample of 500 batteries each and test them for the defect. The result of these tests will be then used to estimate the percentage of the defective batteries in the population. Got the point? Yeah, inferential statistics. So we have seen one example of descriptive statistics, in which suppose you would like to find out the, yeah, you would like to calculate the height of the students of your class. So you would like to, what you will do in descriptive statistics, you would count, you would measure the height of all the students, and then you will make a decision what is the minimum height of a student, what is the maximum height of your student in your class, and what is the average height of the class. Yeah, average height of the students in the your class. Okay, but in case of inferential statistics, this is the example. Suppose a company is thinking about the buying 50,000 electric batteries from a manufacturer. It will buy the batteries if no more than 1% of the batteries are defective. Since it is not possible to test each battery in a population of 50,000 batteries, yeah, because it is going to take the time and it is also going to cost the money. So instead of that, what the company will do? The company will select few sample of 500 batteries each and test them for the defects. The result of these tests will be then used to estimate the percentage of the defective batteries in the population. Got the point? So out of 50,000 electric batteries, the company will select a sample of 500 batteries. They will select 500 random batteries and then they will check the defect. Yeah, they will find out. Yeah, they will check it. They will test them for the defect. Okay. So based on the how many batteries are defective out of 500 batteries, they will make a decision. So for example, what is the condition for the company to buy the batteries? The company will buy the batteries from the manufacturer if no more than 1% of the batteries are defective. So for example, out of 500 batteries, let's suppose only one or two batteries are defective. Then the company will proceed to buy the batteries because the company want to buy the batteries if no more than 1% of the batteries are defective. So what is the 1% of 500? 5. So out of 500 batteries, let's suppose one or two batteries are defective, then the company will proceed to buy the 50,000 electric batteries from the manufacturer. But if the company found out of 500 batteries, there are 5 or more than 5 batteries are defective, then the company will apply the result to the population data or to the 50,000 electric batteries, and then they will not buy any batteries because the company has put the condition that the company will buy the batteries if no more than 1% of the batteries are defective. Got the point? So it is not possible for the company to check, to test 50,000 batteries. So what the company will do? Company will select few sample of 500 batteries each and test them for the defect. And the result of these tests will be then used to estimate the percentage of the defective batteries in the population. Got the point? Yeah. So I hope now you have understand descriptive statistics and inferential statistics. Yes. Now let's proceed to the next point, correlation. So what is this? Let's see that. Correlation is a statistical technique for measuring the relationship between the two variables. Okay. So it is a statistical technique which is useful for measuring the relationship between the two variables. It is of the three types: positive correlation, negative correlation, and zero correlation. In a positive correlation, both variables increases and decreases together, whereas in a negative correlation, one variable increases and other one decreases. And finally, in case of zero correlation, there is a no relation between the variables. Got the point? So the correlation is a statistical technique for measuring the relationship between the two variables. So it is of three types: positive correlation, negative correlation, and zero correlation. In a positive correlation, both variables are increases and decreases together, whereas in case of negative correlation, one variable is increased and other one get decreased. And finally, in case of a zero correlation, there is no relationship between the variables. Okay, let me give you the example for positive correlation and negative correlation. So see, positive correlation example. See, the more time you spend running on the treadmill, the more calories you will burn. Yeah. So the more time you spend running on the treadmill, the more calories you will burn. The longer your hair grows, the more shampoos you will need. Obviously, the longer your hair grows, the more shampoos you will need. Okay. So here are the two variables. Your hair, if your hair is increasing, then the amount of shampoo you will need, it will also increase. Okay. That is our positive correlation. Okay. Another example I want to give of a positive correlation is that the more speed of your car, the more distance you will cover in a particular time. Okay. Are you getting the point? The more speed of your car, the more distance you will cover in a particular car time. For example, in 1 minute, 2 minute. Okay. Yeah. Okay. And then the longer your hair grows, the more shampoos you will need. The more time you spend running on a treadmill, the more calories you will burn. So these are the example of positive correlation in which both variables are increases or decreases, yeah, together. Now let's see negative correlation example. A student who has many absences has a decrease in the grades. So the more absences in a class, then decrease in a grade. So here one variable is increases, other one is decreases. So which one? If you count the number of absences, if you count how many absence of a particular student in your class, so a student who has many absences in a class, that student has decrease in a grades. Yeah, so number of absence and number of grades. So if number of absences are increasing in the class of a student, then there is a decrease in the grades. Or else you will understand the next example of negative correlation. If a train increases the speed, the time to get to the final point decreases. Obviously, if the train or if the car increases the speed, the time to get to the final point or the time to reach the destination decreases. So here, speed is increasing, time is decreasing. If the speed increase, the time decrease. So it's an example of negative correlation in which one variable is increasing, then other one is get decrease. So if a train increase the speed, the time to get to the final point, the time to get to reach to the destination will decrease. Got the point? So this is the example of negative correlation. Zero correlation means there is no relationship found between the variables. Okay, got the point? So can you tell me one more example of positive correlation? Yeah, the more the more you study, the more chances of getting scored, or the more chances of scoring the good marks in your exam. Yeah, obviously. But if you study less, then then you will get less marks. Generally, we will talk. Yeah, if you study more, then you will get a good mark, you will get a more marks. But if you study less, you will get a less marks or less percentage. Are you getting the point? Or let's suppose if you drive a car, yeah, in low speed, then low distance or less distance will be covered. Yeah, this means if the speed is less, then the distance covered will be less. Yeah, if the speed is, if you're driving the car in a very low speed, then you will cover a very less distance. Okay, but if you drive a car in a very fast speed, then you will cover a large distance in a particular time. So this is the example of positive correlation. And negative correlation is the example, if you increase the speed, then the time required to reach the destination is get decrease. Got the point? Yes. So now I hope you understand the correlation. So remember, correlation, it is a statistical term. It is a statistical technique for measuring the relationship between the two variables. And there are three types of correlation: positive correlation, negative correlation, and zero correlation. Okay. So zero correlation means there is a no relationship between the variables. Okay. So now I hope you understand correlation also. So now let's proceed to the next point, that is mean, median, and mode. Okay. So see what can we learn from looking at a group of numbers? Tell me. What can we learn from looking at a group of numbers? So see, in machine learning and in mathematics and statistics, there are often three values that interest us. First one is mean, second one is median, third one is mode. So what is the mean? That is the average value. The median is nothing but the midpoint value. And the third one is mode. That is the most common value. Okay. Yeah. So yeah. So what can we learn from looking at a group of numbers? So in machine learning, in mathematics, in statistics, there are often three values that interest us. Mean, median, mode. Mean, the average value; median, the midpoint value; mode, the most common value. Okay, so let's understand each of these terms. Okay, mean. The mean value is the average value. The mean value is the average value. I hope you know that how to calculate the average. Yeah, it's a very basic thing. So, for example, we have registered the speed of 13 cars. So for example, speed is equal to, so these are the speeds of 13 cars. So it look like we have put in the speeds of 13 cars in a list. So speed is equal to 99, 86, 87, 88, 111, 86, 103, 87, 94, 78, 77, 85, and 86. So these are the speed of total 13 cars. So if I ask you to find the average, so it's very easy. To calculate the mean, find out the sum of all the values and divide the sum by total number of values. So see, first of all, find the sum of all these values. So find the sum, that is 99 plus 86 plus 87 plus 88 plus 111, yeah, till 86. So calculate the sum of all these value and divide this sum by total number of values. Since we have total number of values are 13s, yeah, because we have registered the speed of 13 cars, and you can see how many values are here in our list. In our list we have total 13 values. So divide it by 13. So in simple term, to calculate the mean or to find the average, first of all, find the sum of all the values and then divide the sum by number of values. So 99 plus 86 plus 87 till 86, this one. The addition of all these things divided by 13, that is total values. So you will get the answer 89.77. That is the mean value, that is the average value. Okay. So this is the average speed of a car. This is the average speed. Since we have registered the speed of 13 cars, so the average speed of the car is 89.77, or the mean of the car is 89. The mean of speed of the car is 89.77. Got it? So remember, the mean value is nothing but the average value. The mean value is nothing but the average value. So for example, we have registered here the speed of total 13 cars. So you can see the first car speed is 99, 86, 87. Okay. You can consider it as a kilometer per hour, 99 kilometer per hour, 86 kilometer per hour, 87 kilometer per hour. Okay. So how to find the mean? So what you need to do, you just need to do the sum of the speed of all those cars and then divide the result by total number of cars, total number of speeds, or total number of values. So since we have total 13 values, so first of all find the sum of all these values and divide the result by 13, since we have total 13 numbers, 13 values. So 99 plus 86 plus 87, all these things till 86 divided by 13, and you will get the mean or the average speed of the car, that is 89.77. Okay. Now the question comes to you. Mathematically, you know that how to calculate the mean or average, but using the Python, how can we calculate? So see, the NumPy module has a method for this. So good news for us. Using the NumPy, we can find the mean. Okay, the mean value or the average value. So let's see that. So see, example of it. So first of all, the NumPy is providing the functionalities to find the mean. So first of all, import the NumPy. So right, import numpy as np. After that, since we have registered the speed of 13 cars, so let's suppose speed is equal to, okay, and then inside the square bracket we are putting the speed of total 13 cars. So its speed is my list. Now to find the mean of the car, you just need to write, to find the mean of or the average of speed of the cars, you need to just write numpy dot mean. So see here np dot mean, and inside that supply the data for which you want to find the mean value. So I want to find the mean value for this speed, that is my list. Yeah, and this speed list contain the speed of total 13 cars. So we want to find the average of these values, the average speed of the car. Yeah. So it's very easy, just write numpy.mean and then speed. The result of this one you can assign to any variable and then print that. So here you will get the mean or the average value or the average speed of the car. Mathematically, we have found it here. What is the average speed of the car is 89.77. Now let's verify, does we get the same output if you calculate it with the help of numpy? So how to calculate it? We have the method numpy.mean. So np.mean, inside that supply the data. And this speed data contain, yeah, it has the it speed. What is this speed? It's a list that contain the speed of 13 cars. So with the help of numpy.mean, we are calculating the average speed or the mean speed of the car. Now let me run this code in Jupyter Notebook. How to open it? Yeah, go here, search the Jupyter Notebook, you will open it, you will find this window here, and then to open the Jupyter Notebook, access it, paste here, copy it and paste it in your web browser. So I have already done all those steps. Now see here, after that you will see the home page, you will go to the new and then click on Python 3. So you will find a new, yeah, where you can write the code. So see here, import numpy np, so speed, yeah, this is the speed of total 13 cars. So we want to find what is the average speed here or the mean speed. So I will write numpy.mean. So since we have imported numpy's np, so write np.mean and supply the data, that is speed. The result of this one you are assigning to the x and then you can print it. Let me run this code in front of you. You will get the same result. Yeah, 89.7692. Mathematically, how much we are getting? So see, mathematically we are getting 89.77. Now here how much we are getting? 89.769230. Yeah, exact answer. Okay, so this is the average speed of the car. Okay, so remember the mean value is nothing but the average value. How to calculate it? You just need to do the sum of all these values divided by total number of values. So since we have total 13 values, first of all find the sum of all these value and divide it by total number of, so count how many values are here? 13 values. So the sum of all these values divided by 13, you will get the mean. And how can you write, how can you find the mean with the help of Python? So in case of Python programming, we have the NumPy library through which you can easily find the mean of your data. So write numpy.mean and supply the data here. So what data we have? Speed of 13 cars. The result of this one you can assign to the variable and then you can print it. So finally we got the speed of the car is 89.76 kilometer per hour. Okay. Now I hope you understand what is the mean. Yeah. Now let's proceed to the next point, median. Okay. So what is the median? So see here. The median value is the value in the middle after you have sorted all the values. Is it simple? So sort all the values in ascending order and the median value is nothing but is the value in the middle. The median value is the value in the middle after you have sorted all the values. So for example, I have, let's suppose, a set of these values. So see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So see here, all these values are sorted, yeah, in ascending order. So since we have total 13 values, so what is the middle of that? Yeah, 6 on the left side, 6 numbers on the left side, 6 numbers on the right side. So 87 is look like a median. So median value, yeah, is the value in the middle after you have sorted all the values. Yeah, is it simple? So the middle value. Okay, so median value is the value in the middle after you have sorted all the values. So see here we have total 13 values. So this one is our median. So see, on the left side we have total 6 number, on the right side we have 6 numbers. It is important that the numbers are sorted before you can find the median. So please make a note of it. You should sort the numbers before you find the median. Now, if there are two numbers in the middle, divide the sum of those numbers by 2. For example, see here, how many numbers we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now here comes the problem. You might think 6 values on the right side, 6 values on the left side. Then what is the middle term? What is the middle value, or what is the median? So see here, you need to consider these values then. So see, 86 and 87. If there are two numbers in the middle, divide sum of those numbers by 2. So see, consider these two values. So total, how many numbers we have? Total, we have total 12 numbers. So see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we know that 6 and 7. So see, 1, 2, 3, 4, 5, 6, 7. So consider these two values. Okay. What you need to do to find the median of this one? Do the addition of these two values and divide it by 2. So if there are two numbers in the middle, divide the sum of those numbers by 2. So 86 plus 87 divided by 2. So you will get the output 86.5. Okay. So this is mathematically how you can find the median. So if you have total 13 values, so it's very easy. That is the seventh number will be our middle value. 6 on the left side, 6 on the right side. But if you have the 12 values, so what you need to do, you need to choose the two middle values, 86 and 87, do the sum of that and divide the result by 2. So 86 plus 87 divided by 2, you will get 86.5. Now, with the help of coding, how can you find it? So again, the NumPy module has a method for median. So it's very easy again. Import the NumPy as NP and then write your data speed is equal to, for example, speed of total 13 cars. And you need to find the median of this one. So write np dot median of speed. To find the mean, we write numpy dot mean, np dot mean, and then supply the data here. To find the median, so write numpy, that is np dot median speed, and the result of this one you can assign to x, y, z, whatever it is, and then you can print it. Now let me show you the output of this one. So see, we have the speed data. So let's find the median of this one. So see, np dot median speed. So since we have imported the numpy, so don't need to write here again. So numpy dot median, with the help of this one, we can easily find the median. So I want to find the median of this one, speed that contain the speed of total 13 cars. Okay. And the result of this one I'm assigning to the y and then print y. Let me run this code in front of you. Okay. Just a minute. Yeah. Can you see the output? The median for the data speed that contain the speed of total 13 cars. The median of this one is 87.0. Let me run it again in front of you. See, it's 27 become. Yes. So what is the median? Median is the middle value. Yeah. After sorting the values. Yeah. So what is the median? Median value is the value in the middle after you have sorted all the values. So see, the output of these values, we are getting the output. Yeah. The median of this one, we are getting 87 because 87 is the middle number here after sorting the values. Okay. Got it. Now let's find out the median of this data. Okay, so if you have two numbers in the middle, then divide the sum of those numbers by 2. So let's see that. Okay, so for example, you have this data. So see how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So see here. So 3 and these 3. So the middle values, if you have the two numbers in middle, so output which should be 86 plus 87 divided by 2. So 86.5. Let me run this code in front of you. Can you see that? It become 28 and let me run it again. 29. So can you see this one? That is my median. So what is the median value? Median value is the value that is present at the middle after you have sorted the values. The median value is the value in the middle after you have sorted all the values. Got the point? And how can you find, how you can calculate the median? So again, with the help of numpy, import the numpy as np and then use np.median and supply the data inside it. Got it? So now I hope you have understand how to find the mean, how to find the median. So to find the mean, do the sum of all this data, all these values divided by total number of values. In case of median, first of all, sort all the values in ascending order and the middle value will be your median. But if you have the two values in the middle, so do the addition of these two values and divide the result by 2. So you will get 86.5. And by the way, even if you don't remember how to calculate mathematically, so just remember how to write the Python code to find the mean and to find the median for your data. So if you have this data speed, so write np.mean of speed to find the speed, to find the mean data, to find the average value of this speed of the car. Even if you want to find the median, yeah, of the speed of the car, so write numpy.median. np here is numpy. As we have imported numpy as np, so np.median of speed. Got it? Yeah. Now let's proceed to the next point, that is mode. So what is this mode? So see, what is mode? The mode value is the value that appears the most number of times. So it's very easy. The value which occurs the most number of times, it's your mode. What is mean? Mean value is nothing but the average value. Median will be the middle value after you sorted all of your values in ascending order. And the mode is nothing but the value that appears the most number of times, the value that has the maximum number of count. Okay, for example, if you have a speed of 13 cars, so see here we have registered the speed of 13 cars here. So if you count it, this 86 number occurs most number of times. So that is my mode. What is the mode? The mode value is the value that appears the most number of times. So see here, this value 86 is appear most number of times, so hence it is my mode. So but it's easy for us to count as a human, it's easy for us to count a particular value. Yeah, how many times 86 occurs, how many times 87 occurs in our data set. But with the help of Python program, how can you find the mode of the values? So mode of the value is the value that appears the most number of times. So see, use the SciPy mode method to find the number that appears the most. Okay, so to calculate the mode, we need to use the SciPy, yeah, scientific Python. Use the SciPy mode method to find the numbers that appears the most number of times. SciPy is a free and open source Python library used for scientific computing and technical computing. SciPy contains modules for optimization, linear algebra, integration, interpolation, spatial functions, signal and image processing, and other tasks common in a science and engineering. Okay, so to calculate, to find the mode value, you need to use the method mode which is present in the SciPy library. So what is that SciPy? SciPy is a free and open source Python library for scientific computing and technical computing. SciPy contains the modules for optimization, linear algebra, integration, interpolation, spatial function, signal and image processing, and other tasks common in science and engineering. Okay, now in order to find the mode, so we need to have the SciPy library. So first of all, import it. So from SciPy import stats. Okay, from SciPy import stats. It's very important. Okay, and then make a data. So that is my speed that contain. That is nothing but the speed. What is this speed? It's the list that contain the speed of 13 cars. We have registered the speed of 13 cars. Now to find the mode, right stats. So this is right, this one stats.mode and supply the data. And the result of this one you can assign to the variable and you will find the mode. So what is the mode? The mode value is the value that occurs, that appears most number of times in your data. Yeah. The mode value is the value that appears the most number of times. So you are going to use SciPy, and from the SciPy you need to import stats. So from SciPy import stats and then use the method stats.mode and then supply the data into that, and the result of this one you can assign to the variable and then print it. Now it's time for us to write, to execute this code. So see here, from SciPy import stats. Okay, after that, what the data you want to have? So I want to have the speed data, that contain the speed of 13 cars, that is in the form of list, and then I will write stats.mode speed, and the result of this one I can assign to any variable and then print it. Let me execute this code in front of you. So can you see that mode result, mode array 86, count array 3. This means 86 is my mode and the count for is 3. So see here, 86, 1, 2, 3. So the mode value is the value that occurs most number of times in your data. Now I hope you understand what is mean, what is mode, and what is median. Got it? Now let's proceed to the next point, quartiles. Okay. See, a quartile is a statistical term describing a division of the observation into 4 defined intervals based upon the values of the data and how they compare to the entire set of observations. The quartile measures the spread of the values above and below the mean by dividing the distribution into 4 groups. A quartile divides the data into 3 points: a lower quartile, median, and upper quartile to form 4 groups of data set. Quartiles are used to calculate the interquartile range, which is a measure of variability around the median. Okay, so see here how the quartile work. So I hope you understand what is quartile. A quartile is a statistical term describing a division of the observation into 4 defined intervals based upon the values of the data and how they compare to the entire set of observation. Quartile measures the spread of the values above and below the mean by dividing the distribution into 4 groups. A quartile divides the data into 3 points: a lower quartile, median, and upper quartile, to form 4 groups of data set. Quartiles are used to calculate the interquartile range, which is measure of the variability around the medians. So how the quartile works? Let's see that. A quartile divides the data into 3 points: a lower quartile, median, and upper quartile. So we know what is median. Okay, let's see what is upper, lower, and upper quartile. So see, as the quartile divide the data into 3 points: a lower quartile, median, and upper quartile, in order to form the 4 groups of data set. The lower quartile or the first quartile is denoted as Q1, and it is the middle number that falls between the smallest value of the data set and the median. What is the lower quartile? Lower quartile is denoted as Q1. It is a middle number that falls between the smallest value of the data set and the median. What is the median? Yeah, median value is the value that is the middle value. Yeah, the middle value of your data after sorting your data, after sorting the values in ascending order. Yes. Okay. What is the quartile? What is the lower quartile? Lower quartile is denoted as K1, and it is the middle value. It is a middle number that falls between the smallest value of the data set and the median. The second quartile Q2 is also the median. Okay, the median is also second quartile. Okay, or you can say the second quartile is also known as median. The upper or third quartile denoted as Q3, and it is the central point, or you can say the middle point that lies between the median and the highest number of distribution, or you can say the last number of the data point. What is the Q1? The lowest quartile. Lowest quartile, it is a number, yeah, it is a middle number. It is the middle number that falls between the smallest value of the data set and the median. Whereas the upper quartile or the quartile 3, it is the middle number that falls between the median and the highest number of the distribution. Got the point? So Q1 lower quartile, Q3 upper quartile, Q2 is nothing but the median. Okay. So now let's suppose you have this data set 1, 3, 3, 4, 5, 6, 6, 7, 8, 8. So how many numbers we have? First of all, find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since we have 10 numbers, so what are the values in the middles? First of all, check whether we have the data in ascending orders. Yeah, whether the data values are sorted. Yes, it is sorted. Yes. Before you going to decide the median value, make sure your data are in sorted. So see, I have the data, I have the values in sorted, yeah, in ascending order. So here total 10 values are there: 1, 3, 3, 4, 5, 6, 6, 7, 8, 8. So how many numbers are there? 10 numbers. So the middle values will be 5 and 6. So if you have the two numbers in the middle, what you need to do? You need to do the addition of these two numbers and divide the result by 2 to find the median. So see, the middle quartile will be 5 plus 6 divided by 2, that is 5.5. See, example 1, 3, 3, 4, 5, 6, 6, 7, 8. The numbers are already in ordered. Yeah, the numbers are already sorted. So cut the list into the two quartiles. So first of all, cut the list into two quartiles. So 5 and 6, that is the my two numbers. In this case, quartile 2 is half away between 5 and 6. So 5 and 6, do the addition of this one, 5 plus 6 divided by 2. So you will get 5.5. That is the median. Or you can say that is my quartile 2. Okay, so once we find this, okay, and the result is Q3, sorry, Q1, quartile 1. So what is the number between the smallest value and the median? Tell me. 1, 3, 3, 4, 5. So which look like the middle number here? 1, 3, 3, 4, 5. So out of these 5 numbers, the middle number is 3. So that is my first quartile. What is my second quartile? Second quartile is nothing but the median. So we have calculated the median, that is 5.5. Now what is my third quartile or upper quartile, Q3? It is a middle value between the median and the highest number of the distribution. So see, 6, 6, 7, 8, 8. So what is my middle number here? 6, 6, 7, 8, 8. The middle number look like 7. So that is my upper quartile. So Q3. Got it? And the interquartile range is nothing but Q3 minus Q1. So Q3 minus Q1. What is Q3? 7. What is Q1? 3. So 7 minus 3, 4. Got it? Yes. So now I hope you understand what is quartile, what is lower quartile or first quartile, what is upper quartile or third quartile, what is the second quartile or you can say the median. Okay. First quartile, it nothing but Q1, that is the lower quartile. Second quartile, Q2, that is the median. Third quartile, Q3, that is the upper quartile. Got it? So lower quartile or the first quartile is the middle number between the smallest value and the median. Whereas the upper quartile is nothing but the middle value or the middle number between the median and the highest number of your distribution. And the median, we know that the middle value of the data after you sorted the data. Okay. So see here, since we have total 10 numbers, 1, 3, 3, 4, 5, 6, 6, 7, 8, 8. So what is the middle two values? 5 and 6. So to find the median here, do the addition of 5 plus 6, 11. 11 divided by 2, that is 5.5. So my median or the second quartile will be 5.5. So once we find it, so it's easy to calculate the first quartile. So see, we have 5 numbers on the left side, 1, 3, 3, 4, 5. So the 3 here is the middle value. So that is my first quartile or lower quartile. And then what is my upper quartile? Upper quartile is the middle number between the median and the highest number. So this is my median and the highest number is 8. So what is the middle value here? It looks like 7. And then interquartile range is nothing but Q3 minus Q1, that is 4. Got the point? Yes. Now let me show you this code. How can you find it? So see, quartiles. As we studied, quartile is a type of quantile. The first quartile is defined as the middle number between the smallest number and the median of data set. Remember it. The first quartile is defined as the middle number between the smallest number and median of data set. The second quartile is nothing but the median of the given data set, while the third quartile is the middle number between the median and the highest value of your data set. So for example, I have this data 133, 4, 5, 6, 6, 7, 8, 8. So see here, we have taken the same data, and then with the help of Python program, let's find the lower quartile, upper quartile, and median. So see here, this is my data which is in the form of list. So first of all, find how to find the median. We know that. So right, numpy dot median. Yeah, we know that how to find the median. Np dot median is speed. So what is my second quartile? Now median is nothing but my second quartile. So np dot median of data, that is my second quartile. The result of this one I will assign to q2 and then print q2. But what is my first quartile? First quartile is the, what is the first quartile? First quartile, see here, is the middle number between the smallest number and the median of the data set. So since I have a total 10 numbers here, 10 values here, so I will find the median of the data from 0 to 4. So 0, 1, 2, 3, 4. Yeah. Or you can say 5 values from the left side. So I will write 0 to 5. And then I will write, yeah, 0 colon 5. That is nothing but that represent this data. Yeah. NP dot median of data of, what is the meaning of this one? By the way, data is my list. If you write data of square bracket 0 colon 5, so it is going to select the numbers from 0 to 4. So 0, 1, 2, 3, 4. So 0 colon 5, this is nothing but this one. So I need to find the median of this one. That will become my first quartile. So np dot median of data square bracket 0 colon 5. The result of this one you can assign to the first quartile and then print the first quartile. What is my second quartile? Second quartile is nothing but the median. So I will just write np dot median of the data and I will get q2. And then the third quartile. What is the third quartile? Third quartile is the middle number between the median and the largest value of the data set. So by the way, you must think your data set should be in order. Should be, yeah, in ascending order. Yeah, so see here. Now the third quartile. So np dot median of data, and then I will write 5 colon. So from the fifth index position. So see, fifth index position is this one. From fifth to last one. 5, 6, 7, 8, 9. So 5 colon nothing. This means start from fifth index position to the last one. So because the third quartile is defined as the middle number between the median and the highest and the largest value or the highest value of the data set. So start from the middle number. So np dot median and then data of square bracket 5. Yeah, that is this one. 5 colon. Don't write anything till the last number. Here initially 0 colon 5 for the first quartile, and for the third quartile 5 colon dash 5 colon left the number. So here comes the third quartile. The result of this one you can assign to the q3, and then interquartile range is nothing but q3 minus q1. The result of this one I'm assigning to iqr and then print it. Now let me run this code in front of you and let's see the output. Yeah, it is run. See, it's 31 currently. Let me run it again. So it will become 32. See here. So the first quartile coming here 3.0. Is it correct? Yes, can you see this one? The first quartile 3. So with the help of programming also we have calculated the first quartile is 3. What is my second quartile? 5.5. Can you see this one? Yes. Can you see this one? 5.5. Yes. 5 plus 6 divided by 2, that is 5.5. Yes. That is my second quartile. What is my third quartile? 7.0 here. This is my third quartile. 3.0 is my first quartile. 5.5, that is my second quartile, or you can say the median. And this is my third quartile, 7.0. So how we find here? Can you see this quartile Q3, upper quartile 7? Got it? So the same output we are getting here. And finally, interquartile range we are getting 4.0. So is it correct? Q3 minus Q1, that is 4. Got the point? Yes. Okay. Now even if you want to find, yeah, the quartile, the first quartile, second quartile, third quartile of some other data. So for example, I have this data, data 1. So how many numbers we have? Check it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So if you count it, there are total 20 numbers. And all these numbers are already sorted. Now I can use the first quartile, np.median of data 1. And then first of all, I will write 0 colon data 10. Since I have total 20 numbers, so write 0 colon 10. Because the first quartile is the middle number between the smallest value and the median. So data 1 square bracket 0 colon 10. That is my first quartile. After that, to find the second quartile, that is the median, I will just write np dot median of data. Yeah, to find the second quartile. I have not written it. Okay, you just write np dot median of data 1. Now to find the third quartile, I will write np dot median of yeah data 1. That is my this data, and then inside square bracket 10 colon last number. Okay, since I have total 20 numbers, so I will, for a first quartile, I will make data 1 of square bracket 0 to 10 and then 0 colon 10. This means from 0 index till 9 index, and then 10 colon nothing. 10 colon nothing means from the 10th index to the last value. That is my third quartile, 10th quartile 3. And then calculate the interquartile range Q3 minus Q1. Let me run this code. Can you see this one? Yes, this is my first quartile. This is my third quartile, and this is my interquartile range. Now let's proceed to the last point, standard deviation. So see here, I have written it. Standard deviation is a number that describe how spread out the values are. A low standard deviation means that most of the numbers are close to the mean value or average value. A high standard deviation means that the values are spread out over a wide range. Okay. Standard deviation is a number that describe how spread out the values are. A low standard deviation means that most of the numbers are close to the mean or average value. A high standard deviation means that values are spread out over a wide range. Example, this time we have registered the speed of 7 cars. So see, speed of 7 cars. Now we can again going to use the NumPy module, the NumPy library, and we are going to use standard method, STD, standard deviation method, to find the standard deviation. So I have the speed of 7 cars. So speed here is in the form of list with that will show the speed of 7 car, and then I will use np dot standard deviation std. So with the help of the method std, I can find the standard deviation of your data. So numpy dot std and supply the data speed, and the result of this one you can assign to the x1 and then print x1. Let me run this code in front of you. So see here, the output I'm getting here is 37.84. Okay, even if you want to find the mean of this one, so np dot mean of speed. So see, the mean of this one is look like 77. Or else don't get confused with this one, make it as a speed one. You might think speed is already there in the above code, so make it as a speed one. Let me run the code again. So this is my standard deviation and this is my mean. Yes. So see, the standard deviation is a number that describes how spread out the values. A low standard deviation means the most number of that. A low standard deviation means that most of the numbers are close to mean. So see, it's look like mean is 77 here and the standard deviation is 37. So a low standard deviation means that the most of the numbers are close to the mean. Okay. In our data set, in our data, the most number of the values, the most of the numbers are close to the mean. Okay, don't get confused. Standard deviation is the number that describe how spread out the values are. A low standard deviation means that most of the numbers are close to mean. Okay, a low standard numbers are a low standard deviation means that most of the numbers are close to the mean value or average value. A high standard deviation means that the values are spread out over a wide range. Okay, and then we have seen how to calculate the standard deviation. So write numpy.std and then data. Got it? Yeah. So finally, I hope you have understand all the concept of this session. So we have seen introduction to statistical analysis. What is statistical analysis? Introduction to mathematics and statistics. Categories of the categories in statistics. Yeah. Okay. And what we have seen? Yeah, we have seen correlation also. Yeah. and we have seen mean, median, mode. Yeah, we have seen the quartile, and we have seen the standard deviation. Yes. So I hope now you have understand all the topics that we have seen in this session. So thank you very much for attending this session. Have a good day. Keep learning. Bye bye.